Okay, so a unitary matrix, by definition, a unitary matrix, or maybe let's talk about the idea of unitary matrix. The idea of unitary matrix in the complex plane and orthogonal matrix in the real plane or the real space is that it preserves the norm, it preserves the angle between vectors, the length of the vectors, the inner product between vectors. This is the idea of unitary and orthogonal matrices. So let's start from the beginning. The definition of a unitary matrix is that you take the U conjugate transpose U equals the U conjugate transpose, which equals I, which equals the identity matrix. Now again, the unitary and orthogonal matrices are very unique in that they preserve the lengths and the angles between vectors. Therefore, they preserve the inner product and preserve the norm. So if you take an unitary matrix and an arbitrary vector and you multiply them and take the norm, you will find out that it's like taking the vector itself and taking the norm. The multiplication with the unitary matrix didn't change its size a bit, so it didn't change the norm. As we said, it doesn't change the norm, it doesn't change the inner product. Now, a very important idea of unitary matrices and orthogonal matrices of the real plane is that the columns of a unitary matrix and orthogonal matrix the columns build an orthonormal basis. Namely, the columns are orthogonal to each other and each column is a unit vector, is normalized. Okay, so for real matrices, unitary becomes orthogonal, and instead of conjugate transpose, we are getting into transpose. So U transpose U equals I. Now the determinant of a unitary matrix is of absolute value of 1, and the eigenvalues also lie on the unit circle, so their absolute value is also 1. So this was in a nutshell about unitary matrices and for real matrices, orthogonal matrices. Thank you very much, and that's it.